Hello guys, this is Edward from Pt2. This is the continuation of the revision exercise on atomic structure. So we'll continue to look into typical examination question under atomic structure. And before we continue, in case you haven't done so, if you are new to the channel, please subscribe to my channel, like the videos, drop a comment if you have any question, and do not forget to turn on your notification bell so you get notified whenever a video like this is dropped. Which element has the highest third ionization energy? Before you answer this question, you need to understand the factors that affect ionization energy. Okay, and the factors are, we have distance, and by distance I mean the atomic radius. Okay, number two, we have the atomic nuclear charges. Okay, the nuclear charges. And by number three is shielding. If you check my video on ionization energy, I have explained I explained the concept of how these factors affect ionization energy. Then also you need to know the trend of ionization energy in the periodic table. So we know that across the period, the ionization energy increases. Okay, it increases across the period and then decreases down the group. Okay, so let's look at the options here. Lithium belongs to group 1, beryllium belongs to group 2, potassium belongs to group 1, and calcium belongs to group 2. All right, so now across the period means that if you have, let's say we have now we have lithium and beryllium. Okay, this is group 1, this is in group 2. All right, so beryllium is having, will have higher ionization energy than lithium. Okay, all right, so now group 1, group 2 basically will have higher ionization energy than group 1. So all the group 1s here are eliminated, right? Lithium and potassium. Now you are left with calcium, beryllium and calcium. Now between beryllium and calcium, we know that down the group, the ionization energy decreases, right? So which of them is higher in the periodic table? Now beryllium is higher than calcium in the periodic table, right? Because beryllium is 4, calcium is 20, right? So as you can see here, now calcium is going to have a lower ionization energy than beryllium because of what they call the distance, the atomic radius. Now the distance between the atom, the nucleus rather, and the last shell of calcium is larger than the distance between the atoms, the nucleus of beryllium and the last shell. Now this is what I mean. For calcium, we have, let's assume this is the nucleus, right? We have 2, 8, 8, 2, right? And for beryllium, now let's assume this is the nucleus. Now we have 2, 2. So look at the distance between the nucleus and the shell, and the outermost shell and the shell. You can see that the distance is greater in calcium than in beryllium. So hence the force of attraction between the nucleus and the electron in the third in this shell, because the third ionization energy starts from here, right? It's going to be from here. This is the first and the second, then the third one will be from here, right? So the atomic radius is larger in calcium and compared to in beryllium. But in beryllium, the third ionization energy starts from here, right? So we have this. So basically, beryllium is going to have the highest stored ionized energy. Our answer is beryllium. So this says, which atom contains the most neutrons? Which atoms contains the most neutrons? Uh, this is chromium, this is manganese, this is iron, and this is nickel. So first you need to know the atomic number, that is the number of protons they have, right? And mass number is equal to the proton plus neutrons, right? So you're looking for the number of neutrons, and neutrons therefore will be equal to the mass minus the number of protons. So you check your periodic table and check the number of protons these elements are having, that is this the atomic number of these elements here, right? So chromium is 24, manganese is 25, and iron is 26, then nickel is 28. All right, so let's look at the number of neutrons that they all have. All right, so for chromium, 54 minus 24 will give us 30, right? For manganese, 55 minus 25 will give us 30 as well. All right, and for iron, 57 minus 26 will give us 31. Okay, for nickel, 58 minus 28 will give us 30. So which of them contains the most neutron? That is iron. Okay, the first 6 ionization energies in kilojoule per mole of an element are, so we have this data here as a the first 6 ionization energy of an element, right? 1, 2, 3, 4, 5, 6. Now you are asked to identify the element. Now I remember in one of my videos when I was explaining ionization energy, I told you that you could be asked to identify an element based on the data of their ionization energy, right? So it can come in this form, okay, or it can come in the form of a graphical representation. So you could be given a graph and you have something like this, and you ask to identify the element that this data belongs to. Okay, so it's easy, and this is what we're going to do. The first thing to do is this. Now look at the data here from 1 to 6, the emission energy. Now where do we have a greater spike or a greater increase? I mean, a very obvious, great increase in the energy. Now if you look at 1, 2, 3, and 4, they're basically within the same range. Like the difference is not that very significant, like just 1,000, 2,000, 4,000, 6,000 plus, right? Now from 5, look at the value of 5. You have 37,800, and 6 you have 47,000, right? So now this basically shows that we have entered into a new shell. All right, so whenever you see a spike, a very significant spike, a spike increase in ionization energy, it shows that you have entered into a new shell. All right, a new shell that is closer to the nucleus. All right, so now in this case, now this 2 shows that this 2 ionization energy comes from the electrons closer to the nucleus, right? So now we're going to have something like this: 1, 2. Then the remaining 4, basically they have similar ionization energies, although the increase is though, but the spike, there is no significant spike in there, right? So basically it means that they belong to the same shell. They belong to the same shell. 1, 2, 3, 4. So now we have this 1, 2, 3, 4. All right. So now which element conform to this configuration? 1, 2, 3, 4, 5, 6. That is carbon. Okay, I hope that makes sense. In which pair is the first ionization energy of atom Y greater than that of atom X? So let's look at the options here. So atom X, for option A, the atom X has 1s2, 2s2, while atom Y has 1s2, 2s2, and 2p1 configuration. So now what you need to do is this. First of all, represent you fill in the electrons um, into its subshell. The last orbital here is 2s, right? 2s2. Now filling the electrons of 2s2 into its subshell, and s has just one subshell, right? So one subshell. So this is 2s, 2. The 2 electrons are then filled into the subshell. This is for x, right? Now for y, we have 2p1 as the last orbital, right? And the electron is on 2p1. The last electron is on 2p1, right? So and p has 3 subshell. So for 2p1, we have this. Okay, 1, 2, 3, and we have just one electron. So the one electron will occupy just one of the subshell. All right. So now you can see here you have 2 pairs of electrons. Here you have 1 pair of electron. It will be easier to remove this electron that is standing on its own compared to the electron that is paired. Right. So in this case now, Y will have a lesser first ionization energy compared to X. Okay. So here X is greater. X is having greater ionization energy than Y. So A is not our answer. And let's look at option B. Option B, let's look at the last orbitals, 2p3, 2p3. Let's represent the 2p3. Okay, and the first electron, and remember the rules involved in writing electron configuration. It says that you fill in the subshells first with single electrons before pairing them, right? So we have 3 electrons. You're going to have 1, 2, and 3. So there's no more electron to pair, right? And let's look at for Y. Y is 2p4, 2p4. So let us fill in the electrons in its subshell of orbital, 2p4. So we have this. Okay. So first of all, you have your first electron 1, 2, 3. Now you have 1 more electron. Then you can pair these electron. So where is it going to require much energy to remove electrons? Now you can see here 1 paired electrons, rather, that's 1 paired electrons in one of the subshell, and this, because it has 1 pair of electrons, it's not stable. Now most of the orbitals want to attain stability. Most of the atoms want to attain stability, right? So for this to be stable, it is either it is half filled, like in this case here, or it is completely filled with electrons, with pairs of electrons. But in this case, you have only just 1 pair of electron here, so that will make it it will be easier to remove this electron here. So the ionization energy required here will be lesser than in X. So say the same thing, X here will be having greater first ionization energy than Y. Okay, so B is not our answer. Let's look at C. Now C, we have 2p5 and 2p6. Okay, so let's represent 2p5. Okay, you have 2p5. So let's put the 5 electrons. We have 1, 2, 3, remaining 2. So you pair this one 4, and you pair this one 5. Okay, that's for X. Then for Y, we have 2p6. 2p6. So we have this. We have 1, 2, 3, 4, 5, 6. As you can see here, the orbital is completely filled. So it required higher energy, or more energy rather, to remove electron from 2p6 compared to 2p5, but because 2p5 has 2 pairs of 2 paired electrons, okay, and it has 1 unpaired electron, okay. So this 1 unpaired electron is not, it's not stable, right? This orbital is not stable because of the presence of 1 unpaired electron. So it will be easier, it will be easier to remove 1 electron from 2p5. And also, besides, if you look at this electron, this orbit, this element rather, this is a noble gas, right? In noble gas has a completely filled orbital or noble element. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the last shell is completely filled. So it has attained its stability. It will be difficult to remove electron from here, right? Compared to this other atom X that has 5 electrons in the outermost shell. That has 7 electrons in the outermost shell rather. Okay, so C is the correct answer. I hope that makes sense. Alright guys, that is the end of today's lesson. I hope with this revision exercise you have been able to fully comprehend the concept of atomic structure, and you'll be able to answer any examination questions on the atomic structure. And if you haven't done so, please subscribe to my channel, like the videos, drop a comment if you have a question, and do not forget to turn on your notification bell so you get to be notified whenever a video like this is dropped. See you some other time.